Hi, I'm Tom D and I want to show you a simulation when node leaving cluster and causing cluster failure. This is related to situation when node left event triggers replica shard allocation despite of available resources and therefore might overflow rest of nodes with data. Let's start. First step is to create the volumes, data volumes. They are only 2 MB in size. So it's easier to create smaller files that will exceed the available disk space later on. Start first node, let's name it Europe01. Non-default setting for JVM because otherwise it will fail. When other nodes will try to join this node to form cluster. You need to check if node is started. It's started right now, so you can set the password for Elastic user. Password is set up right now. Save the enrollment token under the token variable and start other nodes. Other nodes are started. To confirm if they are up and running and forming the cluster, you can run the command cat nodes, and it's visible that all 3 nodes are right now up and running and forming the cluster. Before loading the data, you can create the mapping. The mapping contains the information about, this is basically the settings for the index that contain information about the number of shards and number of replicas. So every primary shard will have its replica. And there are 6 indexes that I'm creating. There is customer data 1 up to 6. Now I prepared 3 files in IPFS storage. There are 3 different, basically there are 3 different PNG files, the image files that will be converted later on to base 64 representation of this data. So it's kind of random data. It's hard to compress. Images are hard to compress. That's why I'm using images here, because if I'm using text, the Elasticsearch can compress the data and it's hard to estimate how much data need to be inserted to simulate this failure later on. So let's import that files. There are the 3 PNG files right now. Now conversion to base 64 format. Then writing this to JSON file so it can be bulk loaded later on. The JSON file is created. Now it can be bulk loaded to customer data index. Customer data index 1, customer index data 2, and customer data index 3. Now the second file, the second image, converted to JSON file. And time to load it to customer data 4 index. Now the third image, and now time to load it to customer data 5 and customer data 6. Now when you check data allocation, first cluster health is green. Now data allocation, all primary and replica shards are allocated. And what about the disk storage? Disk storage shows that there is a 1 MB here available, there is 800 kilobytes, 400 kilobytes, and this is the data usage and disk total. So now I'm going to kill one of these 3 nodes, and I am expecting that node left cluster event will trigger replica allocation, which basically moves too much data into the rest of the nodes and will cause failure of the whole cluster because there will be no disk space left. Let's do this. docker kill Africa01. And now let's check the disk space. It's showing that the disk available is almost exactly the same as it was, but important is to check the shard allocation, because right now these replicas are not assigned. Expect one of the replica is here, but it was already on Europe 01, so it's fine. I didn't kill that node. I killed node Africa 01. So now it's 1 minute that will pass, and these replicas will be forced to be assigned to some nodes. Now when you try to check the status of, for example, the shards, you keep on waiting until it will show you the error that master not discovered exception, reason null. The reason for this situation is that once the node left the cluster, it triggers the allocation of replica shards. And this action can't be stopped. This is the default action of Elasticsearch. When node left the cluster, the allocation of replica shards happen. In this case, because there was very little disk space on the other nodes, it caused the cluster to be unstable because there is no disk space on the nodes that are in the cluster right now, and cluster cannot operate. Remember to visit my blog, toughcoding.net, where you can find the latest articles about the same content as was presented on videos, plus additional non-presented content. To avoid that situation, you need to avoid having nodes in a cluster fully occupied. So there is always a disk space to handle that replicas that might be pushed into nodes when one of the nodes leaving the cluster.